Daniel Grotti from Sipwise, because you are here. And welcome to the Sipwise workshop, and thank you for coming. Today we are going to take a look to our SIP provider community edition, which is our software version of our class 5 soft switch based on Kamailio. So what is the SIP provider C? Is a turnkey appliance for basically real-time communication. So basically a class 5 soft switch where you can manage subscribers and peers. Basically, of course, for voice, video, presence, and instant messaging, is based on SIP and XMPP for the presence and instant messaging part. The carrier solution, so the one we tested in lab with our servers, our Dell servers, is an environment that can reach up to 50,000 subscribers and till 2,000 parallel calls. The software is based on Debian as operating system and some other open source blocks and Sipwise project blocks, as well as Kamailio, Prosody, Asterisk, MySQL, SEMS, and so on. We released Sipwise released the first release in December 2010. So far, we reached the 16th release, which is the MR 3.8.1. Soon, I think, soon, we should release our next long-term support release, which should be 3.8.2. So far, since 2010, we got around 31,000 downloads from the website. Around 1,000 downloads per month. This is a chart showing the monthly C downloads from the website since end of 2010. So the agenda for today is to show you how to bring up SIP provider C on a virtual machine, register some clients and test some calls between SIP clients, and try to make a couple of test calls with WebRTC. We are going to configure a little bit the web interface, the system, through the rewrite rules in order to rewrite callee and caller numbers. I will show you how to configure peers, but actually we don't have any peers here. How to configure the billing, how to create a billing profile for a customer. We will have a brief look at the architecture of the SIP provider. look at the configuration files, how to manage the configuration files, how the frameworks inside the Sipwise works. And was supposed to let you use the bridge interface of the Wi-Fi. I don't know, Daniel, is working? Daniel is working the bridge, the Wi-Fi bridge it's working? Okay. Okay, I'll check it together. So in order to set up the virtual machine, we are going to download Vagrant and VirtualBox on our laptop, and then we're going to bring up the WebRTC Vagrant file from the USB stick. We should have some USB stick if one of you want to grab the files. The only thing we need to do is to download and install Vagrant and VirtualBox, and then run these two commands to bring up the virtual machine. I already bring up the virtual machine on my laptop. With Vagrant SSH, you can basically access the Sipwise and you will have the web interface reachable on your IP on port 1443. Administrator is the default password, and sudo -s to become root. The platform allows you to handle the system as a own main administrator of the system, but also can allow you to create a reseller. So a reseller can use the home system and resell the traffic to their subscriber. The system is multi-tenant, so you can create multiple reseller, and multiple reseller can create his own domain, home customer, subscriber, billing profile, and rewrite rules. The default reseller, the reseller with ID 1, is the administrator. In order to create a reseller, it's quite easy from the web interface. In the reseller page, you can create a reseller with default values, or you can create a reseller with a contact. You need a contract. So you need to specify a contact like name and surname of the reseller. You need to associate a billing profile. So once the reseller is created, basically the administrator just create a administrator login user associated to that reseller. Once the reseller is created, he can access the web interface with the admin with his own credential, and then he got pretty much the same settings as the administration. Actually, less, because the reseller cannot handle peerings. Also, he can brand the panel. And then, of course, can create customer subscribers. The first thing you need to do is to create a domain, which will be your SIP domain. It can be, of course, a URL or the public IP or the main IP of the system. It will be used from Kamailio to bind on for the SIP signaling. So for now, we will create the domain with the IP of the virtual machine. Domain has preferences you can configure, and basically the preferences of the domain will be by default the preferences of each subscriber under that domain. You can specify different preferences for subscriber as well, and the preferences of the subscriber will take precedence on the preferences of the domain. For example, you have preferences like use RTP always with plain SDP. In your domain preferences, it will apply on all your subscriber. But if you want to change that preferences on the subscriber level, you can set up another, you can change the setting of these preferences, for example. So we are going to create an IP, a domain with our IP from the web interface. Yeah, we have a duplicate entry. Okay. This is because the domain was already created by the vagrant box. We already have we can use this one, this domain. This domain is assigned to the default reseller in this case. Once you have created the domain, you need to create the subscriber. The subscriber that actually is connected to the SIP device, so it's contained the SIP credential, actually belong to the customer. What we call customer is basically the billing container, and the customer will have a contact identifying him, a billing profile, so a contract balance, so cash to use to make calls, and inside this customer container we can create the subscriber. So before create the subscriber, you need to create a customer. So if we go to the main menu, to the menu settings, customers, we need the contact identifying this customer. It will associate to this reseller, default one. You need to specify at least an email. The customer needs a billing profile because it's the billing container, and all the call associated to make by the subscriber belonging this customer will be rated under this customer. So the invoice goes to this customer. Once we create the customer inside the customer, in the details page, you can see information about the customer, so which reseller the customer belongs to, the contact details, which billing profile is associated. You see now here the subscriber menu where we can create the subscribers. You have the contract balance, so the current total of cash or free time you can use, and the spent cash in this interval. Fraud limits you can set for this customer. But basically, now we can create the subscriber. Under this customer, the subscriber needs to be associated to one domain, of course. We can specify an E164 number in the format E164. And basically, the other fields you need to set are the SIP username and the SIP password. Once the subscriber is created, in the details, you can see some main fields. So the web username and the web password are used to access the customer web interface. You see the SIP URI and basically the primary number. You have here the call history page to see the call from this subscriber, the voicemails received, and the current registered devices. So we create the subscriber. By creating the subscriber, you automatically create the SIP entity and the XMPP entity, so you can log in via SIP device or via XMPP device with the same credential. And basically, we can now try to log in with a SIP client. We can also enable this TLS, which should be enabled by default, I think. Basically, the TLS is a general configuration settings in the main configuration files for the system, which is this one, etc and GCP config YAML. This is a YAML file, which is used by the system to build all the configuration files of each process. So TLS, in the case it's not enabled, we need to enable it. We can specify a different port and certificate. So we can try to log in with the SIP phone. So we can see now here Blink user agent is registered with this contact on this subscriber. We can create actually another subscriber under the same customer, for example. Another thing we can do, for example, is to create in the domain preferences, we have these preferences for the domain where we can configure some parameter like concurrent max call, unauthorized inbound calls. What we can do is to, for example, assign and create a sound set and assign the sound set to this domain. The sound set contains predefined sounds file for the system. of course, you can upload your own file or your own WAV files, but by default we support English right now. But the C has already some WAV files, for example, for the conference bridge, and for the yearly reject messages. In order to apply the sound set, we need to assign this sound set to the domains.
Try again later.
So basically, if Alice now calls Bob,
The number you are
we got
trying to reach is currently not available.
an available
Try
message
again
instead
later.
of nothing. By default, also the
You have no messages.
voicemail
Press 2 to change phone.
is created by default with the subscriber. What we can try now to do is WebRTC by default, and out of the box, the C provider C binds and listen on these three WebSocket. We need to tweak a little bit the configuration in order to be able to communicate between WebRTC client and a SIP client, for example. Basically, we can use Bob as a WebRTC subscriber we just created before, and Alice has a SIP username, SIP device. We need to change some preferences in the NAT and media flow control menu. Basically, we need to change the use RTP proxy to the value of always with RTP proxy as additional only ICE candidate. And we need to tell the system to use the protocol RTP SAVPF, so encrypted SRTP with RTCP feedback to communicate toward the WebRTC client. This was test for Chrome version, and it worked. Of course, as I said, it depends on the WebRTC you are using. You may need to change this these two parameter. In the other hand, on the other side, on Alice, which will be the SIP device, we just need to change in this case, we can change the domain preferences and tell the system to talk with this client always with plain RTP. We can try to use JS SIP as WebRTC client. So we have Bob here. We have SIP at password was Bob, and 3, 4. And then we have here the IP of the SIP provider. With port 5060/WS. I don't have the webcam. So the user is registered. Bob should be up here. So in the subscriber preferences, we are going to change the use RTP preferences to RTP additional ICE candidate. You have several options. And we are going to change the transport protocol. Also here you have several options. In this case, we're going to check the SRTP with RTCP feedback. And the domain preferences, so this will be applied to always with plain SDP and transport protocol. RTP. It's ringing at least. So it's working. We can test the. Sorry? Surprising, yes, surprising. Usually doesn't. And at least we have this. So the Larsen effect is
VoIP engineers, right?
Yeah. So what? So rewrite rules. Rewrite rules are basically the dial plan of the platform. Now I just use the SIP username to call each other, but basically you have two possibility to reach the devices through the SIP username or to the E164 number, which basically is a number alias of the SIP username, and also you can add several alias to each subscriber. Basically, when the system receives the call, the call is an inbound call for the system, so the system will take basically the from username and the request URI, and will try to rewrite the number based on your rewrite rules. in particular based on the inbound caller and inbound callee rewrite rules. Then the from basically and the request URIs are rewritten. The system will check the destination based on these rewritten numbers and select the destination, which can be the peer or another another subscriber inside the platform. Before relying the call to the subscriber or to the peer, the system will apply the so-called outbound rewrite rules, again for caller and for callee, so you have the possibility to rewrite the caller and the callee again before leave the platform. Basically, if you have a call from a local user, first the inbound rewrite rules of the domain assigned to that user will be applied. Then the system will check the destination of the call, will select the destination. If the destination is a peer, the outbound rewrite rules of the assigned to the peer will be applied. And if the destination, for example, is another local user, the outbound rewrite rules of the domain assigned to that user will be applied. Actually, the rewrite rules can be assigned to the domain, so all subscriber under that domain will be use the dial plans, or can be assigned to each subscriber if you want to differentiate some subscriber to another, and also it can be assigned to the peerings, because you may have need to use different rewrite rules between peers and domain. So through the settings, the rewrite rules, you can define your rewrite rules. It's in regular expression. So we can create the rewrite rules for the domain, for example. So for example, you have, we want to rewrite local number into E164 number, because our internal subscriber are has assigned to them E164 number, so we want to rewrite everything to E164 number. So the pattern matching will be this one. In the rewrite rules, we can also use some variable like $CC, which means that we are going to rewrite the local number with 0 using the caller country code in this case. So we are going to do the same for the callee. And for example, for the outbound rewrite rules, we are going to rewrite E164 number to international format, which we are going to basically prefix the 00 in front. So once the rewrite rules is created, we can then assign it to the domain. So both of our subscribers will use this number manipulation. And now basically, if I try to call from Alice to oops. So now I can reach Bob, calling Bob. Or calling has a local SIPDB negotiation failed. No. Oh, problem. Let's try to call Alice. Oh, 1, 2, 3, 4. Five, 6. Okay, so I can reach Bob with Alice with the 0 in front. Okay, peerings, we are not going to test any peerings because we don't have any peerings to test. Basically, we support enum lookup for enum numbers. It must be enabled on the config YAML under Kamailio proxy section. And then we can create the peerings, and basically every non-local user, non-local calls, the system will try to send it to the peer. We can allow, for example, foreign domain to go out, so we can able to call foreign domains through our platform. We can unauthorized inbound calls if it's if it's needed. And we can otherwise create the peering rules, the peering groups, which will basically contains your peering server. We have peerings section. We can create a peering group. Inside the peering group, you can create and add your peering server. You can have one or more peering server, and then you have to add your peering rules. So basically the rules that the system should match in order to select this peering. Fuck. So basically the peering group has a priority value you can use to prioritize your different peering groups. Highest priority is 0 and lowest priority is 255. There is basically the selection of the peer is based on the peering rules. If you have the same peering rules, if one call matches two different peering rules in different peering groups, the priority will be used to set the peering groups as first trying. And once the first trying is set, the one of the peering server configured inside the peering groups will be chosen. There is a weight for the peering server you can set, but it's just a number telling you the probability that that peer can be chosen against the other one. So basically it's a random selection. And of course, if the first selection fails, there is an auto failover to the other peering group inside peering server inside the peering group, unless until the peering servers are finished. If everything fails, there are an auto failover to the next peering group with the lowest priority. The peering, as I said, also can handle the. You need to. You may need to add the peering rules to fetch the callee. Also, you can add the rewrite rules in order to rewrite calls that goes out via the peering peering server or calls that is coming from the peerings. The billing profiles is basically assigned to the customer because the customer is the building container. Basically, you can add an off-peak times of that billing profile, so you can specify a fee, a rate for the on-peak and off-peak. You can charge all your or define your billing fees, and you need to specify in the billing. So, for example, you can specify a billing profile that have 20 cents to call German on fixed line, or 30 cents per minute to calling Germany mobile or Austrian fixed line, whatever. The Sipwise Community Edition doesn't support the prepaid billing, so only the postpay billing is available. The commercial version of the SIP provider can support, of course, both. Basically, the SIP provider Community Edition is doesn't support all the features we support in the commercial version for of course, because it's for free. Yeah, we supposed to be finished for the technical part, and we would like to check a little bit the architecture inside the SIP provider. This is the picture regarding the SIP provider Pro, because you have two nodes. The Pro version is sold in high availability. The SIP provider C basically is only this part because it's a software version and doesn't have the hard availability module and some other blocks here. Basically, we have an SNMP monitoring, which is not supported on the CE. I can read. We have the REST API interface, which is supported by the CE as well. We have the web interface, the CDR exporter, and the customer self. So in the customer interface where the customer can access and then can handle his profile, his voicemail, can check the CDR, the call list. We have the billing machine and the mediation. Basically, the CDR. Kamailio just create the entry in the ACC table, and then we have a script that creates the CDR in our internal CDR table, which is the mediator process. And then we have the ratermat process that takes this unrated CDR and actually rate the CDR, and then the CDR is exported also in the CSV format. The database is based on MySQL, and then we have some additional modules that actually is not supported by CE, like, for example, the Cloud PBX module, which allows you to handle and create Cloud PBX inside the class 5, the calling card module, the fax server, which is not also supported on C, the low full interceptor module, mobile push voice sniff is for the SIP sniffer to create to sniff the traffic and see the call flow from the web interface. The high availability module based on Heartbeat, and then we have the XMPP server based on Prosody. The SIP signaling is based on Kamailio, and we have RTP engine for the media relay. Basically, the 5 main components are Kamailio, SAMS, Asterisk, and RTP engine, and Prosody for the XMPP. We have inside the server, we have two instances of Kamailio. One is called load balancer, and one is called proxy, which actually acts as proxy and registrar server. The only instance of Kamailio which is exposed to the external world is the load balancer, which is actually a stateless proxy, and then inside binding on the local host, we have the stateful proxy and register server based again on another instance of Kamailio. Then we have SAMS, which is act as a back-to-back user agent and also provides some functionality like conference, so it can be also incorporated in the SIP application server, which basically stays for conference, bridge, and voicemail. Voicemail is the only features done by Asterisk. Then we have the media relay, which is basically RTP engine. The signaling call flow is the blue line. So basically, we have a incoming call, SIP call, hitting the SIP load balancer, which is actually the only instance binding on the public IP. The SIP load balancer just has a stateless proxy, just relay the message to the proxy server, which is the main engine and brain of the server, which decide the call route. Once everything is decided, it relay the message to the back-to-back user agent, so to SAMS, which actually split the call in two legs and do some header manipulation or codec filtering and so on. And then the calls get back to the SIP load balancer that will send out the message to the callee. Once the call is established, the media path will be the red one. Basically, we set depending on the RTP preferences, RTP proxy preferences. We set that basically we tell all other devices that our media relay IP is the one binding, the one used by RTP engine. And yeah, basically we handle all the traffic through RTP engine here. The configuration framework, everything is based on templates filed and on YAML configuration file. We have three main configuration files containing the main parameters and variables for the system, and those variables are used by the templates file to build actually the real configuration file. For example, the Kamailio CFG is a templates file, and the template files use parameter inside the YAML files to create the real etc Kamailio.cfg file. The config file we saw already before, basically contain some general configuration parameter for each. It's divided in section, asterisk, CDR export, and so on. Then we have the constant file, which is not used actually by the end user. It's just contain username, password for the internal connection between processes and, for example, DB. And then we have the the network file that specify the network configuration and basically which type of service we want to run on each IP. We can decide to run SSH on this IP. SIP external is basically the where the load balancer should be bind. SIP internal is where the proxy should be bind. All these parameters are used in the templates. In the templates file, which basically replicates some configuration directory for example, Kamailio, engines, prosody, asterisk. So if we check the Kamailio, we have this so-called Kamailio CFG.tt2 file, which basically is a dynamic file, and the file is built. The real file is built automatically by this dynamic file. How it's built? It used the so-called NGCP CFG framework. So basically, as soon as we change something and we want to apply the changes we made on the templates files, we need to basically run the NGCP CFG apply command, which basically commit your changes on the Git repository inside the CE and generates all the real file from the templates file and actually restart all the service that were affected by your changes. The best way to change a default configuration file is to create so-called custom tt.tt2 files that basically will be a copy of the default file where you can change whatever you want inside. But if the system notices that a .custom tt.tt2 file exists in the directory, the custom tt will take precedence on the default file. Another reason to do that is that if you upgrade your system and you upgrade your templates packet, your change will be lost because the default configuration file will be overwritten by the new templates. That's it. If you want to have more information about provider CE, you can submit to our mailing list, which is this one. We have also exposed documentation about CE version on our website this is the website related only to CE version. The Sipwise.com is the Sipwise related to the commercial products.
Can Sipwise do DTMF detection?
DTMF, yes, I mean it's...
From inbound to us?
Yes. both. No, basically, I mean, the DTMF we support is the one, if the DTMF ends on the platform, for example, if you need to access the voicemail, in that case, we use asterisk and we handle both way. On other hand, if the connection is hand-to-hand, we don't basically don't do anything.
Don't convert it.
No. We don't do any codec, we don't do any transcoding for the coding, at least so far. So the code, the RTP and whatever is outbound is transparent.
What's your favorite codec?
Favorite? Mine? No, I mean, it depends. What at least you have to support is the G711 because voicemail works on G711A. Also, at least you have to support that. Any other codec you can use the codec, whatever codec you want, because we are transparent, so we don't care actually. Okay.
Just a feature, if you support this, the register smoothing when you have many subscribers falling away and then coming back, and you have 3,000 CPs registering. Those 3,000 CPs come back and register, and all for 20 minutes or more. So every 20 minutes.
Yeah, you mean, yeah, it's like the DOS attack or DDoS attack, or? Yeah, we have a against this kind of attacks or problems in the configuration file. In the LB section, you have the security section, so-called security section. We can handle two types of, let's call attack. So basically, we can handle, for example, if we receive a burst of messages in a very short time from the same IP, we can specify the request density per unit. So in this case, by default, is 50 requests in 5 seconds. So basically, if we receive a burst of 51 whatever SIP message from the same IP in 5 seconds or less than 5 seconds, the IP will be banned for 5 minutes. Also, you can enable or disable the fail authentication. So basically, if somebody is trying to sniffing your credential and try to authenticate, is trying to register or authenticate and failing authenticate more than 3 times in a row, the system will be the user that the malicious user, the subscriber that the malicious user are trying to using will be banned for example, 1 hour. This kind of information are also logged in the Kamailio log. All the logs are under this directory, var log and GCP. So basically, you can build up also a fail to ban solution if you don't want to use Kamailio memory to ban the user, the IP. You can ban actually the user directly on IP tables using fail to ban. for example. I think we run out of the time. I don't see Daniel around there, but okay. Thanks.